Hello friends, I am Dr.V Deshpande, Shivaji Arts, Commerce and Science College, Kannad. Now today, equation of continuity. According to equation of continuity, if the net charge crossing a surface bounding a closed volume is not zero, then the charge density within the volume must change with time in manner that the time rate of decrease of charge within the volume equals the net rate of flow of charge out of the volume. This statement of conservation of charge can be expressed by the equation of continuity, which we shall derive here. As we are now dealing with the charge in motion, let us consider that charge density is rho, which is a function of time. The transport of charge constitutes the current, that is I is equal to, that is current is equal to dq by dt, that is rate of flow of charge, which is equal to d dt of volume integral rho dot dv, where we have considered that the current is extended in space of volume v. This is volume v, small volume, closed by the surface S. S is the surface. ds is change in surface. The net amount of charge which crosses a unit area normal to the direction of the charge flow of the surface in unit time is defined as the current density J. J is the current density. According to all experiments, to rate net charge in a closed system is always conserved. Therefore, if a net amount of current is flowing outward a closed surface, the charge contained within that volume should decrease at the rate, that is I is equal to minus of dq by dt, where I is the total current flowing through the surface S. If J is the current density, then the definition total current I is equal to integration surface integral of J dot ds. Now from equation 2 and 3 we get surface integral of J dot ds is equal to minus of dq by dt, which is equal to minus of d dt of integration over volume v rho into dv using equation 1. Now because it is rho which is changing with time, we can write d dt of volume integral of rho into dv is equal to volume integral of dou rho by dou t into dv. Now from equation 4, surface integral of j dot ds is equal to minus of volume integral dou rho by dou t into dv. From divergence theorem we have surface integral of j dot ds is equal to volume integral of divergence of j into dv, so that the equation 5 becomes integration over volume divergence of j dv is equal to minus of volume integral dou rho by dou t into dv, or volume integral in bracket divergence of j plus dou rho by dou t is equal to dv. Now equation 6 holds for any arbitrary volume. We can put integrand equal to 0. Now from this dV is not equal to 0. Therefore, divergence of J plus dou rho by dou t is equal to 0 and is referred to the equation of continuity. It is mathematical expression for the conservation of charge. It states that the total current flowing out of some volume must be equal to the rate of decrease of charge within the volume, assuming that charge cannot be created nor destroyed. That is, no sources and sinks are present in that volume. In case of stationary current, charge density at any point within the region remains constant. Now at stationary current, dou rho by dou t is equal to 0 and substitute this value of dou rho by dou t is equal to 0, we get divergence of J is equal to 0 or del dot J is equal to 0, which express the fact that there is no net outward flux of current density.